Perfect. All right. Thank you all for coming this morning. There are a number of other excellent talks you could be listening to, some of which I would like to hear myself, so I appreciate your coming by. This is the second talk I've given about System D. If you, Luke Crawford, and Rick Moen know the answer to the quiz question on the next slide, you can't shout it out. I just mentioned that the text, well, except for this, in this presentation that's blue, it actually corresponds to a hyperlink. So if you want to photograph the slides, I won't stop you, but all the information is linked from the PDF and the open document format version of this talk. In addition, if you have a laptop, as so many of you do, rather than urge you not to type and pay attention, this talk has a little bit of a tutorial aspect where if you have a system that's running System D, even if it's not entirely converted to System D, you could try typing some of these things in your own system just to understand a little bit better how the tools work. And if you do that, then in your bash history, when you leave, you'll have some useful tips and tricks included in there. So to begin with, my quiz is, what is the most widely used, the most widely deployed Linux init system? Who knows? Just shout out the answer. Come on, guys. This is a really pro audience. What's the right answer? Not by units, I don't think. You're close. Who said that? The answer is Zygote. Zygote, which is the init process for Android, which is not System D, which is not sys5 init, which is not Upstart, and which is not even LaunchD, is the winningest, the most popular init system for Linux. So clearly, everything that we're about to discuss here is pretty much irrelevant. So with that behind us now, that we're fighting so hard for second place, let us continue to consider more of the topic at hand. This is not a political talk or a rant. I have subtopics in here that I could rant about, but I'll try to control myself. I'm going to talk primarily about the design and the philosophy of System D, how it's put together, and why it was made that way. I will compare it a little bit with sys5 init, mostly so that I think having a mental picture for how these systems work, even if you don't have to get into the innards that much, helps you understand error messages or syslogs, things like that. Most users, System D is just going to be that the format of the messages in the syslog is going to change, and you're going to type system control start instead of service start, and it hardly is going to make any difference. So I think this whole storm is going to pass and be mostly forgotten in a couple of years. The real motivation for System D being integrated into so many different distributions of Linux really comes from its integration with the Linux kernel. LaunchD, which inspired System D, made by Apple developers, runs on Apple systems, but System D, because it is so tightly integrated with the Linux kernel, really can't run on other operating systems. And the integration of System D with the Linux kernel is really the differentiating feature that has led to its wide adoption. And along the way, I want to sort of give you some tips on what some of the tools are in System D and how to use them. So, yes? There was somebody from the SCaLE AV team here, but okay. Yeah, I don't see any controls on this. So to me, the real motivation for this talk is that a lot of people won't believe it, but I actually think Linux is at the pinnacle of its success and possibly has some real threats to it. The reason I think this fundamentally is because I work in automotive Linux. I write software that runs in cars, run some cars on the road that are on the road right now. And in automotive, somebody told me at my employer not to say this, but I paid for this trip, and I took yesterday as a vacation day. So I am going to say that I know that in automotive, Linux is giving market share back to QNX. In other words, companies switched from QNX or Windows embedded to Linux, and they're going back to QNX. Ford very public, and I can't say who they are, but Ford very publicly switched from Windows embedded to QNX. You may say, I hate cars, I don't care what software runs in cars, but let's face it, if an industry that's for the first time installing general purpose operating systems is not choosing Linux, you should be concerned. It looks like, as I was just discussing with Don, that Linux is conquering the cloud, and Linux is all things to all people, and Linux is running on the New York Stock Exchange. But Linux is in competition with other operating systems, and Linux could use. Just last week, I watched, for the first time somehow, the movie Pirates of Silicon Valley, and there in 1980, Bill Gates is saying Microsoft may not have the dominant operating system forever. He was right, and I think we need to stop fighting with each other and fight our actual enemies. To me, our enemy is closed source software, not some other Linux distribution, and certainly not some init system. So, having said that, I want to talk a little bit about the design of systemd. This talk is populated with pictures from Wikimedia and from my friend's Flickr. And since systemd is at some level an init system, I liked this tree of traffic lights, which apparently all function asynchronously and concurrently. So that introduces me to the topic of the design and the philosophy of systemd. The real idea behind systemd is to extract duplicate functionality from all those bash scripts, put it in one place, write it in C, optimize it, make it more secure, more stable. And so some of the stuff that's coming out of those scripts is moving to the Linux kernel, which I'm going to talk about in the second half of the talk, if I don't take too long in the first half, and some is moving to the systemd core. So yesterday there was a really good talk by Stephanie Lockwood-Childs about USB drivers, and one thing that she said that struck me was there are host drivers that are hardware or device specific that talk directly to the drivers, to the hardware for USB, and then there's the USB core. And the bugs are always in the host drivers, which are device specific. They're not in the USB core. Now, why is that? Well, that's because all the USB drives use USB core, and so if someone else finds a bug in USB core, it fixes your USB drive as well, potentially. And so the same thing is going to happen with systemd. As systemd itself improves, the initialization of everything is going to improve. Now, of course, systemd has bugs in it. Systemd has documentation that's lacking. Systemd, is like any other piece of software. It's not perfect. And I have my own criticisms of it that I can elaborate on if there's time. But the other fundamental concept is to replace all those etsy scripts that are often hundreds of lines long, many of which no one has looked at for years and years, with short declarative configuration files that are essentially lists of properties. And so that probably is completely inscrutable to anybody who's not looked at these files, but I'm going to show you some. So systemd is very similar to a daemon that you may already have on your system, especially if you're an embedded developer like me. Systemd's design involves lazy initialization of services based on socket activation. And so for years, as I think Rick pointed out the last time I gave this talk, we've had xinetd, which is a daemon that started TFTP or started SSH when a regular Unix socket, an inet socket, was probed by a connected device. And systemd, at its grossest, lowest level, is a daemon that lazily launches system services when a Unix domain socket is probed. So in some sense, it's a lot like extending the service activation concept that we've had for many years with xinetd to all the system services. So I will argue that systemd is a good piece of software because it's very modular. It's broken into little bits, which are easier to understand. It's very asynchronous and concurrent, which I'll explain. As I said, it's described by declarative properties. So instead of having scripts, we have descriptive properties files that have Boolean or string values that I'll show you a couple of. It's bundled with a lot of analysis tools and tests, and the tools are really easy to use and really very featureable and largely self-documenting. And it can be addressed by a variety of different language bindings. So the two parts of systemd that normal users are most likely to see are units and targets. So let's start off by jumping in there. So because the boot is asynchronous, the targets are essentially synchronization points where a whole collection has to come together to create a successful target initialization, and the next target won't start until the previous target finishes. And I'll show a diagram that makes this a little bit more clear. So the most popular targets that you most likely use are multi-user target, which is similar to run level 3 that you're used to, and graphical target, which is similar to run level 5. And because systemd really has made an effort to maintain backward compatibility with commands that you're used to, even now if you type 3, if you append 3 to the boot args of a systemd system, it will boot into a text console. So there's a lot of things like that where the systemd developers, if you don't want to know that systemd is running, you don't really have to think about it. So the philosophy behind systemd for the most part has been to give you new features if you want to read about them and explore them, and to not make you learn about them if you don't care. So another feature that I think makes things a little bit easier is a lot of the choices and configuration are made by symlinks. All the configuration files in systemd are ASCII, unless your distro, if your distro insists on having a SQLite database in your .config that has some systemd properties in it, that's not systemd's fault. But systemd's own files are themselves all ASCII, all the configuration files. And so a lot of the management is done by symlinks. Basically, if you have symlinked default.target to multi-user.target, you boot into the text console. If it's symlinked into graphical.target, you boot into the graphical login. And of course, you can create your own targets, and I'm going to show you a little bit about creating your own services in a minute. And a lot of the tools that you're used to will still work, and systemd has its own tools like system control isolate that will allow you to change run levels. So system control is the command when interfacing with systemd that you'll probably end up using the most. It's featureful to say the least. So the unit files are similar to the scripts that you used to have in a init.d. What the unit file does is specified by the exec start command. The dependencies of systemd, which are really the core of the configuration, are specified by words like before, after. I think that's pretty obvious. We also have requires, conflicts, and once. Once, well, maybe when I show more about the dependencies, I'll talk about that. But so each service that is a user service is requiring and after the basic.target, which kind of brings up the fundamentals of the system, all the mounts, all the devices, the file systems, and they all conflict with shutdown.target. And so this is kind of the orchestration level with these special targets that come on every system. And then there are many kinds of unit files, which, as I said, are similar to the scripts in init.d. The ones that you deal with the most as an ordinary user are the services and the targets, which are like the targets are like the run levels, and services are the most common kind of units. So that's a little bit of vocabulary. So here's my first kind of type along. This system is a Debian system, Debian testing, the rolling release of Debian. And when I started working on the first version of this talk in October, I showed all my demonstrations in a Fedora QEMU because Fedora had so much more integration with systemd than Debian does. But actually, in the months since I started working on presentation of this material, Debian is about 70%. This Debian testing is about 70% converted to systemd. So, good question? I was just going to ask if it was Debian testing. Yeah, it's Debian testing. So, let's see. So I was just going to show you a little bit about dependencies here. Whoops. So listing this is an example of one of the subcommands that system control has, list dependencies. So is this big enough, this font? No. Okay. How's that? Okay. Maybe I better full screen this. So if I say system control list dependencies basic.target, and so now you get this ASCII graphics. You can kind of see, well, you can see there are green bullets here on the side for, okay, thank you, yes. So you can kind of see there's a tree structure here, and these are all corresponding to the different unit files and the services that are running on this system. So these are the dependencies of basic.target, which is kind of the first boot target that comes up, that starts all the utilities, basically. And these are the things that are in it, essentially, the things that it depends on. So there's the sockets, which are part of the socket activation that I talked about. There's sub-targets like sysinit that are doing things like bringing up the console. You can see that Debian has some special sauce called Debian fixup.service. You know, you got EB tables. So this is all kind of obvious stuff. You can see there's a red dot up there. That's because also restore.service has apparently failed. But because basic.target wants also restore.service but doesn't require it, as I'll explain in a minute, basic.target hasn't failed. So there's a whole taxonomy here of different kinds of dependencies. So maybe that's a bit enough about that. I'll show you a little bit more sophisticated analysis. if you try typing these commands, you may have them in your system, but not have them in your $ path. So systemd-analyze is one of the cool tools that comes with systemd. It's in lib systemd. So if you don't have this in your path, you'd want lib systemd-analyze. So let's try that. This talk, I'm afraid, is mainly the audience watching me make typographical errors. There actually is tab completion. It was working in Debian testing for a while, and then it stopped again. I don't know if it's working today. But that says more about Debian testing than about systemd, I think. So this is just a nice feature of systemd. Systemd-analyze spits out this output that can be used for GraphViz, for anybody who's familiar with the GraphViz program. Actually, I just kind of like the presentation of this. And here's the colored legend. So obviously we can, then down here right at the bottom, it tells you, systemd's tools are kind of chatty and pretty useful sometimes. So it tells me what to do here. It says systemd-analyze dot through dot minus t svg into temp. Oh, I forgot to put the target though, so it won't work. So let's say basic dot target. And have to remember this legend while we look at the image. And obviously this is something else that you could type at your system if you're so inclined. My previous talk, I had a couple demos that I probably wouldn't actually be inclined to run, but this talk, I think they're all safe. So here is basic.target, showing all the services to which it's related. So the services that I can't really operate this trackpad, unfortunately. So some of the services are required. So some of the services require basic.target, and then basic.target requires other services, and then there are services that want basic.target and are wanted by basic.target. So the gray ones here are things that are wanted, and the black ones, if I recall correctly, are required. And then there may be some red ones that are conflicts. I don't know. Anyhow, obviously you can make these graphs and scroll around in them to your heart's content. The primary utility of these tools is if you are puzzled by the dependencies, having these plots is really great. So, and another part about this is if you do want to make your own services, the fact that it's so easy to see how the system is set up, it's all example code essentially for making your own services. So a part that took me a while to understand in the beginning is that if you know how dbus works, there's a system bus and a session bus. The system bus is the one that starts when the system boots, and then the session bus is the one associated with your login. And systemd has kind of a similar organization. There's a system interface that, before anyone logs in, has brought up basic dots. Now, there's some complexity. Don and I were talking about before. Also, you can have, obviously, multiple users in the system. See if this actually works now. Okay, so here's the amazing GNOME weather service that I've created comes up and shows today's weather. And how does it know today's weather? If we see what sockets are open and we look up what some of these connections are at the bottom, we can see that it's going out to some Amazon server and some Fedora server, since this is a Fedora QEMU, and it's actually scraping the weather data from there and putting it in the application. Now, let us kill this one and say instead, now I'm going to say system control start, GNOME, start minus user. And so now there's no sudo, but I'm using minus minus user, which means that I'm going to get the service. It's exactly the same service file, but it's coming from the different path. And now when the service opens up, it doesn't show the weather. And that's because it's the user unit. So if I look at what sockets are open, the only socket that's open right now is, I think this is for NTP, has nothing to do with this service. And the other thing that's interesting is, maybe, I forget what, I guess it says right there, it's HTTPS. But, yeah, I don't remember what this service is. Somebody out there probably knows what this port is. Maybe it's DNS or something. But anyhow, the point is, all these other ports open because the system service has access to the location information by default. Whereas if I want the user service to be able to read certain privileged information, I'd have to enable that by hand. So there's a lot of, in the design of this system, there's a lot of thought that's been put into granting privileges kind of grudgingly and making all that very transparent. I mean, I'm a person, I've never run a system with SE Linux turned on. I just can't get my systems to work when SE Linux is turned on. This, I actually understand what protect system, that means that your service can't write to the root file system. It sees a read-only root file system. Protect home, I understand what these do. This is security that's actually simple enough for me to use, which previous security systems in Linux, for me, not being a person who knows a lot about security, have not been. So,
can you use system control --user to log the user out? Force a user off?
I mean, yeah, I don't know. I've never really looked at. There is a systemd login service that starts the user session and integrates with PAM, which I only have a little bit of a vague notion what PAM is, I must confess. The answer is probably yes, but I have not looked into that. So. No. If you let's say I said, with as minus minus user, I say to unmount the root file system or something. What's going to happen is it's not going to find the unit because minus minus. So if I say system control start something without minus minus user and I don't have the SUID, it won't even go and look for the unit. If I say system control minus minus user and the unit is in lib systemd system, it'll say not found. So that was kind of the point of that demo, was that minus minus user and no minus minus user actually look in different paths, because that was exactly the same unit file in the two cases. And so the weather, I was just going to say, comes from libgeoclue. I want to turn to comparison with sys5 init. What I should be doing today is riding my bike with my friends and not taking my vacation to go in LA and give a talk about Linux. Obviously, I'm mentally ill. I wanted to talk about resistance to change in my own life. For years, I had this awesome thing, the toe clip. It was fine. I liked it. I did not want to try this. I complained to my friends. I climb a mountain with this, and my feet hurt. And my friend said, "We are never going to listen to you whine again unless you try the clipless pedals. We are tired of hearing you complain that your feet hurt when you're using the toe clips." So finally I broke down. I spent the money. I got the clipless pedals. I switched halfway. I tried holding onto a table and clipping in and out, and I kept falling over because, of course, holding onto a table and trying to sit on your bicycle is stupid. Finally, I got up the nerve and I went out on the street with the shoes with the big cleats on the bottom and the clipless pedals. I went 50 feet and I said, "Yahoo! I am never going to use toe clips again." So I've overcome my resistance to change, and you can too. Say amen, somebody. So there's been some criticism of systemd. There has been some criticism of systemd. I know nobody believes it. One of the points of criticism of systemd is that it's a big binary. It has, the last time I checked, 5,900 lines of code in it. So that is pretty big, I admit. And people say, "Look at SBin init. It's only 60 lines. Obviously a better program. Does almost all the things that systemd does, and it's 100th as big. You know, it's much better." But I'd like to point out that the real service manager in the Linux we're leaving is bash. It's not really SBin init. And if you look at the size of bash, it's pretty much almost the same size as systemd. Of course, you might say bash has been around a long time. It's well tested. It's a piece of software we trust. At this point in time, how likely is it to have any vulnerabilities? I take your point. So here's just another little exercise that you can try typing along for fun. If you want to see which services are started by sys5 init, like right now in your system, if your system like Debian testing is changing over, you can type ls, etc., init.d, the things that have always been in init.d that were started by SBin init still are. And if you look in libsystemd system, which I already talked about several times, you can see the ones that are started now by systemd. So as I told you, Debian testing is switching over. So if I say ls, etc., init.d, okay, sure. So there's what on this system, fully patched Debian system, is currently still started by etc. init. And then if I say, I'm sorry? I see. So here's what's in libsystemd system. So for all the pain and anguish that Debian has had over systemd, which I personally find very regrettable, now this isn't entirely a fair comparison because systemd tends to have multiple unit files where sys5 init would have one very long file. So the number of listings in here is not entirely a fair comparison. But mostly for all the heartache about this, the point is Debian is mostly switched already. It wasn't that hard. Yes.
So a while ago they were trying to reduce boot times for Linux, and I don't. Somebody at IBM came out with a parallelization idea that would boot the system more in parallel. Does systemd help with that?
Yes, I think that's the next topic I'm going to discuss. Oh, shows it's a good question. Yes.
If there are .service and .socket files for the same thing, which one do you start?
That is the next thing I'm going to talk about. I'll get there in just a few minutes. You guys are you're on the same train of thought that I am. So the major differences between systemd and sys5 init that are user visible, I think, are one is, for better or worse, systemd does not inherit any variables from the environment in which it runs. And in fact, for the most part, this is an advantage because I think it's good for security, and it's also, at the end of the day, it will make it less confusing why things are failing. It's not something in your .config, because systemd doesn't know about that even when you start it knows what's in .config systemd, but it's not looking at your bash RC variables or something. And then the next part is socket-based activation, which kind of has been the headline feature. This lack of inheritance of variables can cause problems. There's a really good article by Neil Brown that was in LWN that talks about how that made a headache for him as the packager of NFS utilities for a lot of the distributions, and that's one of the resources that are symlinked in the end of this talk. Well, let's talk about socket-based activation. So this is one of Lennart Puttering's slides, which I have stolen with his permission. So sys5 init was synchronous and serial. You know, you had the services with their numbers, and that's the order they started in. And let's face it, that's kind of the old world of computing. We don't really do almost anything that way anymore. Upstart was a clever idea in its time, and of course, Red Hat Enterprise Linux went where Leonard Puttering worked for Red Hat. Initially went to Upstart. Upstart has a different design that I could talk about how it's different, but it achieved a certain level of parallelization, and it definitely led to an improvement in boot time. I personally found Upstart difficult to use. I can tell you I had a system I was bringing up for which I had no graphics drivers, and to figure out how to bring up the network without bringing up the graphical user environment was something that took me about 2 to 3 hours to figure out, honestly. So systemd is fully asynchronous and fully parallel. Just an anecdote about that is that in the development work I was doing last spring, I said, my analytical tool is really awesome. I want it to run immediately after boot. So I basically tried to put it in basic.target.once. And upon further reflection, I realized you might realize this process that I wanted to run needed all kinds of services that weren't available until multi-user.target, which comes after basic.target comes up. So what do you think happened? You think my system didn't boot because I tried to start this analysis tool like right after process 1 started? No. It saw it had dependencies on these other services without my understanding it. I was just being a fool. And it started after multi-user.target.once. So when I first saw that, I was like, I wanted to get data right from boot. Why didn't this work? And then I realized, wait a second, why did the system boot at all, right? So I think part of the hostility that some sysadmins have had to systemd is it takes away the previous mechanisms of control, some of them that people had for the system. But at the end of the day, from my point of view, if it works without my always quite understanding it, that's fine. So, so I'm going to talk a little bit more now about socket activation and demonstrate it a little bit. I think I don't know how people react to having all these sort of watching me make typographical errors during the talk, but I think if you see things, it helps make the concepts clear. So one service that we all know about is CUPS. I think it's Common Unix Printing System. So let's say system control status cups.service. So CUPS is running. You can see it's in green here. And the system control status is very helpful. It gives us the PID, all this information about CUPS. So I'm going to say sudo, because I'm controlling the system now, not just inquiring about it, sudo system control stop cups.service. So it says stopping cups.service, but it still can be activated by cups.socket. So now let's say sudo so system control status cups.socket. Uh-oh. This demo may not work. Oh, I typed a period at the end, that's why. Okay, so cups.socket is still running. And in fact, and it tells you that cups.socket is actually in this file var run cups.sock. So cups.sock is actually a regular plain old Unix domain socket. It's not something weird created by systemd developers. So I will demonstrate that by saying, let's send a message to the socket and see what happens. And I'm going to use the tool ncat, which is part of the nmap suite of tools, which is packaged for all common Linux distributions. And I am going to send the message to cups.sock. And here's our response from cups.sock. It sees that I've made an HTTP post request, and so it spits out that it doesn't know error 405. It's an unknown request. Now, if we say system control status cups.service, cups.service is running again. So even though I sent a completely malformed, meaningless message to cups.sock, cups.service has started. And so this is actually how CUPS would be started in the regular boot of your ordinary desktop system. Cups.socket would be started by, I think, basic.target, and that would be it. Cups.service wouldn't start. And then if you open the browser or, say, LPR, then that message will actually go to cups.socket, and it'll start cups.service automatically. So I've been confused by this sometimes where, for example, I'm setting up a board and I want to SSH into it, and I try to type from my laptop to log into the board, and it doesn't work. So I think, oh, SSH probably isn't running. So I go over to the board, and I see, in fact, SSH isn't running, but sshd.socket is running. And so, as usual, it's that I don't have port 22 open or something like that. But it's not the problem that ssh.service isn't running, because as with xinetd, it wouldn't get started until you want it. So that's what lazy activation really is. Yes?
What if you want your service to automatically shut down after a create an activity? Do you do that in your service? That requires some code? You don't necessarily want to.
There's ways to. Right, there's ways to do this with the properties. There's the list of properties you can put in those unit files is gigantic. And just show that the man pages for systemd, I think, are really good. And this is if you're really interested in this, I recommend actually getting the systemd source from the Git repo, just because you get all the man pages in one directory, so you can grep them, which is great. It just I don't know, I just find it very convenient. So if you look in, so the kind of plumbing commands, to use the terminology of Git for systemd, are in sd underscore, and the ones that are sort of user commands are in systemd. And if you look in, this is fascinating video, I'm sure, for whoever is watching. If you look in, anyhow, there's somewhere here, there's something called systemd.unit, and you can look in there, and it lists all the different properties that you can have. I'm getting a major time fill on this. I better motor here. So that's socket activation. I'll say something about the systemd journal. If you've been trying to type the commands I'm typing and you can't run system control status, it's because you need to add yourself to the group systemd journal, which you can do with this command. People have objected to the systemd journal because it's binary, which I can understand, but I think most distributions will simply keep syslog. So there's pretty good reasons to have the binary journal, I think. And if you use it at all, that will, I'll answer your question in just a sec. The great thing about the journal is, as with the unit files, the journal entries from all different services are in the same format. So your system, your service can send any message to the journal, and in fact, anything that your service writes to standard out or standard error automatically goes in the journal, but it gets encapsulated by a metadata header, which is the same for all services. So the journal, like the unit files, is a lot more homogeneous and regular than what we had with the sys5 init syslog. And journal, I'm running out of time, so I guess I won't show all these things, but journal is really easy to use. Journal control minus xn, show the last 10. X means extended, so look at a catalog of descriptions of the services. So this is meant to be user readable. Journal control goes out through a pager by default. If you just want to print the errors, this command will do it. If you just want to look at a particular service, the -u switch does it. You can just look at the last boot. You can compare boots. This is a really great command for using in a script. And then system control, you can, this is get Boolean output is Bluetooth failed. You can just list in it's a failed. These commands are really simple and handy, and they're going to be greater to use in your custom bash scripts, I think, than what we had with syslog, which was kind of grep, awk, and sed chained together in some nasty way that you couldn't remember how it worked for next week. But what's your question?
Yeah, I know you're quick on time, but just to confirm, so you do indeed need to run syslog alongside the
You don't need to.
If you want plain text parsing, or if you want outbound networking logging using syslog formatting, you need to run syslog beside the system logging.
I don't know what you mean by outbound.
Syslog format for sending data over the network to a centralized server.
Uh,
Journal will do that. Yeah. Journal, literally this. It can do both HTTP code and it can also do things. So that's just yeah. Oh, okay.
I don't think I don't think you really need syslog, but I think the thought of Debian is people like syslog. They're used to it. It's not very high overhead. Why not? So I'm going to just fly through this. Right. So there's three features where systemd is tightly integrated with the kernel. One is cgroups, which is a resource allocation mechanism. Here's a couple commands. If you download these slides, you can try these on your system and kind of see how things are going. It's very easy just by putting, once again, simple declarative statements in the unit files to control how much CPU, how much I/O, how much memory your process gets. So once again, this is the sort of thing where Firefox is using all the memory. It pisses me off sometimes. I would never do anything about it because I don't really know how, and I don't feel like spending an hour reading the documentation. Putting memory limit in the unit file is something I could do. I know it'll work. If I don't like it, I'll just take it back out again with Emacs. This is so. To me, the resource allocation and the security systems of systemd are easy enough that I, as an ordinary person who doesn't understand resource allocation or security very well, use them. UDEV, to my personal disappointment, is just about the same and still has the features it's always had. I won't belabor that since I'm running out of time. Systemd does have its own new set of rules now. These are some of the security features I was talking about. They're read-only directories, inaccessible directories. These are just all properties you can set. I think the fact that it's so easy to set up good security for services now will really be a boon for Linux because, SC Linux has gotten a lot better, but I think normal mortals still find it somewhat forbidding. KDBus is the third feature that is going to integrate with systemd and with the kernel. I'm going to give a third and final rendition of this talk at Embedded Linux Conference, and that will be primarily what I'm going to talk about there. That's why I have the kernel with no Wi-Fi drivers that my system boots into by default. I'll just say systemd has a very friendly developer list. You can go on there and see, in fact, that I've asked a bunch of idiot questions and people have answered them very politely. This is how you can get the source. The source, as I said, if nothing else, has the documentation in very convenient format. I think the code of systemd, it's really, really nice. I mean, string equals. Wouldn't you rather use that than string compare if you're a C programmer? Build system has a lot of dependencies, and it's a little bit of a pain. And with that, I'm going to summarize and say systemd, I think, has really a well-thought-out design, has a really good developer community with contributions coming from all over. Its list is flooded now with people from Canonical sending patches. Systemd has caused some unhappiness, and I think more than anything else, this is a reflection of the fact that Linux is run by Linus Torvalds. The kernel team gets to say what happens at the end of the day, really in Linux user space to some great extent as well. And the distros are losing power towards the kernel and towards freedesktop.org that provides a lot of the system software. But I think for Linux to undergo the modernization and compete with QNX and compete with OpenMirage and compete with OSV, it needs to change, or otherwise Linux is going to lose market share, and all this stuff we love, all these companies that are paying for us, Symantec, thank you, that will go away. And so here are my resources that basically particularly the Fedora cheat sheet for sys5init systemd. So thank you all very much for coming, and I'll answer that question back there. Or did I already answer your question?
No, I don't think so. I will make a final comment. Any concern about all of our eggs being in one basket with this group? You talked just about the init system, but we're also talking about the logging system, the UDEV system, the cron system, the network subsystem that's coming out. This is all developed by one group and maintained by one group. So there's a lot of complaints about the single binary blob or
I think the one group idea is really wrong. I mean, like I said, most of the traffic on the systemd devel has been from Canonical, and they're new contributors, and they're getting patches in. There's people contributing from all different projects. CoreOS developers, for example, created NetworkD. That's a network manager replacement. The other thing is you don't have to use a lot of these facilities just because you don't ever have to use the journal. You don't have to use systemd's container system that they've created, nspawn. Who needs another container system? So there's ideas in systemd that I think are kind of bad, but I'm not using nspawn. I'm running QEMU. You can see it. So I think there's a concern there that's real, and people should discuss it. But I think it's kind of been overblown. So yes.
Could you describe briefly how it interacts with like early user space and init RAM-FS, and how it would compare, say, to the old init, RC init kind of, to starting mounting early user space?
Um, yeah, I haven't noticed a big difference there. That's not a question I've really looked into. Things are going to change with KD bus, but once again, that's coming from the kernel, and it's probably going to be in kernel 320. So that's going to potentially be more of a change. Luke?
So you were saying that it's got a slot for your O and O8. Are people putting defaults in there? Does that make sense?
For the properties of the that's an interesting question that I've thought of myself. It seems like it would be a great idea to have templates for unit files that are a guide to package maintainers, and that's something that's lacking that I've thought about. I've thought about myself creating candidate templates and sending patches to the systemd list. There's a couple things that, except that I was preparing this talk, that I think are some little changes like that would be good. I don't know why there aren't template unit files. I mean, in some sense there are, because your system is kind of like, NFS utils or something, so you could look at that one. But it's kind of surprising to me there's not really best practice guidelines. There's more traditional man pages. But since people are changing, that requires more thought. But yeah, I think it's from the names almost. I mean, you almost don't need to read the documentation about the security features because the names are obvious. But yes. Thank you. You have my internal gratitude. Keep my money and not give it all to Newegg.
Thank you. Control just doesn't trip off my fingers like service does.
You'll get there.
I wish they'd chosen a shorter word.
Well, you could make an alias for it.
I know I could, but that wouldn't be standard.
Copy of your presentation or organize it here? Or if you can mail it to them.
It's on. I mean, Shyam Kapadia has it.
Oh, they already have that.
They already have it. Yeah.
Okay. Thank you. You're talking about the presentation?
Yeah, the version is at my webpage, and I gave it to the conference organizers. So.
It was the one from last talk. Have there been many changes from this version?
Yes, there have. It was.
I just want to put a link to it.
So if you look at my. See.
Thank you. That was awesome. Good job.
Oh, thank you. If you look at my webpage. Oops. And you can see. So here's the last talk I gave on this topic, and then this is the new one. And there's also a tarball that has these dumb unit files I made for my demos. They're not going to change your life.
Cat command, subcommand?
Yeah, that's one of my favorites.